Okay, I think I am recording. So hello everybody and welcome to this new Nordic-RSE seminar series. In case you are new, just a quick overview of Nordic-RSE and this seminar series. So I'm now copy pasting this HackMD link in the chat. We will use this HackMD for all interactions today. And so Nordic-RSE is this recently registered organization to bring together and support research software engineers in the Nordics. If you want to join us, that's fantastic. You can check our webpage. We have a membership form. And if you want to chat also, people generally hang out in this Carpentries Zulip chat. The link can be found in the webpage. So come chat, come discuss ideas. And this seminar series started in August of last year, and the idea is to have interesting talks from nice people saying things that are interesting for research software engineers, and it's very, very low threshold. So if you have something that you think is interesting, it's very likely is, and if you want to share it, that's fantastic. So you can open, for example, an issue on the, oh, there's not, okay, yeah, there you can open an issue in the Nordic-RSE website repository to suggest a talk. You can also suggest a speaker if you want. You can discuss ideas in the Code Refinery chat. And if you want to watch previous videos, they're shared in the YouTube channel of the Nordic-RSE, so you can find that there. And our speaker today is Athanasia Monica Movinchkel. I hope I pronounced it decently. And she's a cognitive neuroscientist in Oslo, working in the Center for Lifespan Changes in Brain and Cognition. She has been using R for teaching and research, and she has also been involved in improving gender diversity and equity in the R community. And today she will talk about developing and distributing in-house packages with R. And if you have questions for the speaker, feel free to add them at the bottom of the HackMD or unmute yourself and ask. So Mo, the floor is yours.
Okay, thank you. Really nice to see that so many people were interested in this talk. I didn't know how many people to expect. So this is the first time I'm really engaging with this community, even though I've intended to for a while, but we all know yeah, you know, sometimes it ends with intent and time just runs out. So I'm super excited to be sharing with you a little bit about my everyday work, actually, because I do this quite a lot. So I will start with sharing the correct thing. And once I do that, I'm just going to take 2 seconds to rearrange my windows, because Zoom always ends up putting things where I don't want them. Okay, so I'm hoping you all can see my slide. And if my gaze goes over here, it's because I have a second screen with some notes over here. So I apologize if I look that way once in a while. Okay, so I've already been introduced, so I'm not going to take lots of the time to reintroduce myself, but you can engage with me on Twitter at Dr. Movinkels. Or you can have a look at my repositories on my GitHub account, or you can contact me through my website. So I'm my official position is as a staff scientist at the Center for Lifespan Changes in Brain and Cognition here in Oslo. But a lot of my day-to-day work is really research software engineering, and I'm sure many of you can have a similar type of employment status where your actual title and what you actually do are two different things, because we don't have an official place in the university systems. So I'm a software carpentry instructor and also an RStudio tidyverse instructor. So I really love R. Which also goes to the next point where I founded, and I'm head of Our Ladies Oslo, and I'm also part of the Our Ladies global team. So I engage a lot with the R community. I think it's a great community to be part of. And I think it's a pretty nice language, even though it's quite different from a lot of other programming languages we would usually work in. So let's start with why you should bother with R to begin with as a research software engineer. So I'm not going to go into like why you should bother with R as a scientist or whatever. That is another topic as a whole. But as a research software engineer, why would you bother with R? As R is made for statistics at its core. So it seems like, other than making statistical pipelines, it might feel a bit weird to do a lot of research software development in R. But you really don't have to. Like, if you don't need to use R specifically to solve some problems, like if none of your colleagues use R and you're happy with the software you already know, and you can create transparent and reproducible work in the tools you already know, like then you don't have to spend your time working in R unless the problem you're working on requires some like R idiosyncratic thing. But if you do have colleagues that work in R, it's nice to be able, as a research software engineer, to create tools that are familiar for your colleagues to working. So if they're working in R, they're running analysis, they're working with your data in R, and they have specific problems they need solved, it might be just the best to make that tool in R so that they don't have to learn something completely new to do their work. It's kind of your job to make it a little bit easier for them. It's also a nice way to start helping your colleagues working a bit more transparently and reproducibly. So I'm in psychology, where most of the statistical software is all copyrighted and protected and in black boxes where we don't really know what's going on in the background. It's very hard to make transparent and reproducible work. And R is generally the only open source and transparent software that would be used for statistics in psychology. So trying to transition my colleagues into using R rather than these black box non-syntax running software, I think is good for them and for their career. And it's nice to take advantage of like the huge repertoire of packages that exist in R to do not only statistics, but quite a lot of other things as well. Like this presentation is made in R because why not? But making a package, it sounds like a lot of work. And it is a bit of work. Like we can't, I mean, any software engineering endeavor will require a little bit of extra work. It's not just writing a very simple script and then it works on your computer and then you give it to someone else and it's their problem if it doesn't work. Making a package also entails trying to make sure that it can work on multiple systems. So it requires a little bit of initial efforts to get something into an R package format, but in the super meta way that we love, there are R packages to help you make R packages. So it's good to utilize the repertoire we have to make our work easier for us. And it's nice to give your colleagues a way to work that they're familiar with. So if it's well documented and your functions are stable, that also reduces your future workload, because if your colleagues know how to work in R and they know how to get the help files and you've made good help files, they get their help there rather than having to ask you, which saves everyone lots of time. And obviously you can unit test. There are lots of pros and cons to spending lots of time on making unit tests. I had a period where I was obsessed with making unit tests, making sure that everything ran as it should. And I learned a lot, and it's great. I spend less time on unit tests now, and I just make sure that at least the core things are tested for. But usually a lot of people focus a lot on like making sure that the unit test helps you against when your package dependencies change or something like that. I found that usually unit tests protect me from my future self more than anyone else. Because I look at something I did 2 years ago and I think, oh, I can do it so much better now. I change it and realize that, oh, I made this huge piece of code to fix this one weird thing that happens if you don't do it. And then I have to redo everything back to where it was because I was, yeah. And at least I could see that I made the mistakes because I had a unit test. If I didn't have a unit test, I would never have known I broke something. So, so yeah, there is some work, but the end goal is spend lots of time now, save time later by not having your colleagues to have to ask a million questions. Yeah. And if you after my talk are still not convinced that making R packages is a good idea, if you work a place that uses R, I can really recommend Emily Ryder's talk at RStudio Global last year about making internal R packages part of your team. It's a really good talk about having a good R package actually become like an extra team member. Very much recommend it. That doesn't only go for R, but I think in general, yeah. So how do we make a package? Actually, this slide was in the wrong spot, so let's go here first. The talk, we're going to talk a little bit about identifying and staff needs as a way of work done, and in this case in terms of R. And I have a single slide about some key helper packages that I think are essential to know of. If you're going to make a package in R, they're going to make your life so much easier.
Sorry, I don't know if it's intentional, but we still see only the first slide.
Yeah, you see this. Yeah, that's not intentional. This has happened to me once before with Zoom, actually. And I don't know why. So where did Zoom go? No, this is like the fifth slide, I guess, since I have to. It says screen sharing is paused. How did that happen? Zoom share. Are you seeing it now?
Yes.
Yeah, now I see slide 6. Talk out loud.
Okay, that's ridiculous. Okay. I didn't know I'd paused it. I didn't know you could pause it. 2 years in the pandemic, guys, I still don't know how to do Zoom. Okay, the slides before, I basically already talked through what they said. So hopefully, and I will put them all online so you can see them there as well. Did I have anything in? No, I've talked through them, just making sure. Okay. Yeah, so we're going to talk a little bit about identifying and assessing staff needs and which key helper packages I at least use a lot to make this whole process easier for me. And I'm going to take an example of an in-house package that I made for my work, focus on a subset of that and talk about how it was, the general concepts behind how it was made and why I made it, and how I know it's helped my colleagues. And then at the end, I'll talk a little bit about distributing packages, because at the end of the day, if your staff can't install your package, there wasn't any point in making it. And there is thankfully, there's some new developments there that have made it much easier to distribute packages on multiple operating systems. So cool. I forgot. Did you see me change the slide now? Now I'm gonna become a little bit, yeah, okay, good. So how do we develop packages? So my IDE preference for interfacing to R is RStudio. But I know of people who also use VS Code. I don't know anyone who does that for package development, but I'm pretty sure that can be done. But RStudio has some really practical key shortcuts and so on that just makes package development so much easier when you're working in R. So I can recommend that, or you can try figuring it out in VS Code. So it's good to always start and think about what it is the staff needs. So the three things I see the most happen is people asking me for the same stuff over and over again. That's usually a hint to me that, okay, maybe I should try making something so that they can do this themselves instead of asking me every time. When I hear of or observe them doing things in extremely manual and tedious ways, and my brain just goes, oh, wait, I can make a function for that. Like, you don't have to manually rename these hundreds of files. That is, we can help you do that. The third thing is, especially, I think every lab or every research center has data stored in their own kind of specific way. Like it's their system. It's like they have a specific naming convention or whatever. Our data has a specific way of being saved in a format that was unfamiliar for a lot of the staff to work in. It's ideal for data storage, not ideal for how people usually interface with the data. So having something, having to constantly help the staff read in the data and get the data they needed, I realized, okay, I need to make something that speaks more to them so they can do this themselves instead of asking me to write their data retrieval scripts for them. So then we, as I said before, we have to ask, is R the best tool to deal with this? Our staff is split fairly in the middle between using Python or R. The Python users are not my main concern because they are good at programming, so they can kind of handle it themselves. So that's not a huge issue. The R users, on the other hand, they use R to do their statistics, not necessarily to do lots of programming things. So it's harder for them to kind of sit down and figure out, how do I read how do I read lots of files from the system? How do I change my columns? How do I do all these things? Because they're not used to working that way. And that takes us over to the user level proficiency, like how complicated can my functions be? Or do they need something that is like, I have to make a function that's just called a function that doesn't take lots of extra arguments, because that's just going to confuse them. Where can I do this, and what operating systems are people working on? And I would usually not care so much about operating systems if it wasn't for the fact that I was at a university system where everyone's on networked university Windows computers, and R is not always happy with that. Which is frustrating. And it's frustrating to have to ask IT to do boring tasks to help us work with that. So I have to think about what kind of dependencies I put in the packages. If I know that these are packages that are going to be difficult to install on a networked Windows computer. The joys of our job. Well, it's a challenge, so it's good. So for me, these 5 packages are the things that make my life easier when I make a package. Use this is the king of the hill. It is a package for making packages. That's literally what the package is for. It has lots of helper functions, and I will show you a couple of the helper functions a little bit later. Just even in terms of like adding licenses, it has like some default licenses already in there, and it would add the licensing information in the correct format for an R package. So you can choose from the CC BY or MIT or GPL. Like there's lots of licenses, and it just puts it in there the way you need to. Just really, really nice. It can set up GitHub Actions for you, which is super nice if you want automated checks and set up online documentation. This really is a very, very neat package. RStudio 2 is great. I think it has its counterpart in other types of programming languages as well. But it basically is a package that enables you to make inline documentation of functions rather than having to make a function and the documentation in a completely other file. You can make the function and the documentation in the same file, and RStudio 2 will create the manual file during build. So these are not detached, much easier to catch if you change your argument names or whatever. It's easier to see them when they're in the same place. DevTools is nice for locally loading, checking, and building a package. It's essential for making packages. I'm pretty sure it has to be installed for you to do your job. That is my preferred unit testing package. There are other ones out there, so it totally depends on your needs. I just found Testat to be more intuitive, so that's what I went with. And then R Markdown for documentation as larger like vignettes and user tutorials. Let's see, I have a break reminder that I need to turn off here. So yeah, if you're ever making R packages, I really like install these and start using Use This. Use This is your best friend in your R package making endeavors. So I'm going to show you a little bit of an example package I made. So I'm first actually going to go to the online documentation, and then we're going to have a look at the GitHub repository that the online documentation is made from, and then the package on my local system. So you can see how I interact on my local system. And that means I'm sharing not my screen, but the actual document, which means I have to change. 2 seconds. I want to share my desktop. This time I am not going to pause. Right. So this is the online documentation for a package that I called questionnaires. And what the questionnaire package does is is that we have lots of questionnaires that we send to our human participants, and they answer them. And based on their answers, we want to compute like different sum scores, like of how depressed they are or how much activity they're in every day. Like there are specific ways of calculating these things based on the questionnaires we give them. And we get data all the time, so we need to like rerun these calculations all the time. So I thought, okay, let's make a package that kind of contains functions that would help us make these calculations. And I made this website with a package called package down. So I didn't really do anything. It just takes the content of an R package on GitHub that's gets sourced, and it makes this and deploys it on GitHub pages if you have that enabled. So it's literally almost a single line of code, and then this can happen, which is pretty magical in my opinion. So for instance, here is a documentation. It's a vignette. So it's a user tutorial on the Beck depression inventory. I've added some information with the background about the inventory, and then a little bit about the functions that are in the package and how you can use them to create the sum scores or whatever you need. This is all using tidyverse type syntax because that is what I teach the staff at our center to use when they use R. So if I'm teaching them to use tidyverse type R syntax, that also means that the packages I develop should be tidyverse compatible. So I take the time to develop something that is tidyverse compatible so that it's easier for them to use and understand. So here they can get a bit of information of how to use the functions, and they can even see the function documentations as if they were in R by looking at the references. So it's a very nice, like, and a lot of the time when people ask me like, where did you document this function again? Rather than telling them how to look at it in R, I will just show them the web page because it's easier for them to point and click and kind of go around and look at the different functionalities and what's there rather than get one-on-one help file in R. So if we go to the GitHub repository, which also has a nice quick link on the package on page. I'm sorry, I'm in dark mode. I forgot to change that. I'm sure most of you are familiar with GitHub. So this is just a repository where this package lives. I haven't worked on it for 2 years, as you can see, and I realized yesterday that I need to because there's an error in one of the functions, but everything is contained here and it's in standard R package format. All functions live in R, the manuals live in man, tests are in tests, vignettes are in vignettes. And then there are like the mandatory description and license files and so on. I am guessing this is pretty familiar for most of you. So let's, where are you? There you are. I'm hoping that you can see my RStudio with the very tiny writing. So I hope that's a little bit better. For those of you who have been in RStudio before, number one, I just want to point out that I have my console in the upper right-hand corner rather than at the bottom left. That's because I like to see my scripts in the full height rather than as small. Otherwise, it's a pretty standard setup. And I have here open as an RStudio project my local version of the questionnaires package. So this should map directly onto what I showed you was in GitHub pages and the GitHub repository. I mean, sorry. Once I'm in here and I maybe want to do stuff, I mean, the README is not so interesting. So let's open up the description file. The description file is a key file for making an R package. It basically describes the package name, what it does, who made and or maintains it, licensing information, and what type of dependencies the package has, which obviously is important. If someone's installing it, they kind of need to install the other stuff as well. So doing it like this means that any standard R installation process will also install all the importing packages as well, which are necessary to run. And I can, since I'm in RStudio and I have all the nice shortcuts I want available here, I'm just going to go in the R folder and I'm going to have a look at the VBI functions. So this is how I've organized my functions. Because I have different questionnaires, I've made one file for each questionnaire containing all the functions necessary to do the computations for that specific questionnaire. that was just the tidiest for this specific package. It really depends on how you like. I know people who would put one function in a single file and just have them distributed that way. That's just how people like to work. So we're going to go here. So this is the actual function that's made. I'm going to break a line so we can see what's going on here. It's a function called VBI ComputeSum. It takes data. It takes a tidy selection of columns and a parameter called max missing. And then it calculates a depression score based on the information I know is in the data. But I'm not going to go through the actual code because that's going to be a lot of explanation. And I have to remember what it actually does. And it's been a while. But I wanted to show how we would specify a function in R, which is giving it a name and then saying that this is a function, setting up the arguments of that function, and then running things. On top of here is the Rerun documentation. And I can see that it's Rerun because it has this very specific type of syntax where there's a hashtag and an apostrophe. A hashtag usually in R means that it's a comment. And it isn't comment in terms that it's obviously not code that we want to run, but it's a special type of code. It's a Rerun code, meaning that this should all become manual documentation once the documentation process is run. And I can rerun a documentation process by running Command-Shift-D, which will build, oh, yay, and I have an error in my package. The joys of showing things live, which means I probably, used a package I haven't used in a long time. I swear, no, I tried it on my other computer. That's why it worked this way. Okay, yeah. Now you can document, please, without erroring while people are watching. Thanks. Okay, so now the documentation has been rerun, and I can go to the manual pages. All of these have these are RD files, which are our documentation files. And they've just been created by the Rerun comments. I think their syntax is the RD file syntax I've never learned because I just learned Rerun instead and I found it easier. So as I'm developing things, I usually use, DevTools load all. There's a shortcut on my keyboard, Command-Shift-L or Control-Shift-L if you're on a non-Mac keyboard. Just loads all the functions in the package so that you can work on them. So here are, for instance, all the VBI functions that I have exported so that the users can see them. There are also functions that I do not export. Do I have one in the VBI? No, I have one in, actually don't remember. Yeah, this one, for instance. I have a single utility function that I call 0 to NA that looks through a vector and replaces any 0 with an not applicable instead, which is a special instance in R, meaning that it just doesn't exist. And it doesn't have any Rerun comments and it's not exported, meaning that this is not available for user level interaction, basically. So it's only something that's used internally in the package to do its work, but the user doesn't get access to it because I mean, I could, it's not something that would matter if they had, but I try to make sure making a package that I only export the functions that I think are meaningful for the user to have access to, or else it can end up being a bit like overloaded with functions. Where's my cheat sheet? Yes. So where did it go? Okay. One thing I want to point out that I am assuming this works also in other programming languages. I don't really develop packages or extensions to other programming languages, so I actually don't know how that works otherwise. But in R, a function can also return data rather than, well, I mean, I guess it always returns data. But for instance, here, I've made a function called edu_levels. And the reason I made it is because we've been gathering data on our participants for 14 years now. And I can tell you that we've asked about their educational levels in quite a lot of different ways during those 14 years, which means we have several ways of coding education in our database. And this is a bit confusing. It's confusing to all of us. So I made some functions that could help people map the different types of educational categories that we have. So if I ask for educational levels 4, because I found data that has 4 categories of educational levels, and they're coded in a way I don't understand, I can see that, okay, the data we have that has 4 educational levels should be primary school, high school, university level below 4 years, and university level above 4 years. But if I find data that has 9 categories, that's a whole different issue. So this is also ends up being, and we use this internally in the package to convert, for instance, the 9 level factors into 4, so that they can kind of be merged into a single vector and used in an analysis. It's a proxy, but it at least allows you to kind of build on your data a bit more. So we use this internally in the package that way. So not only is it a good lookup value if you need to look up what your data actually contains, but it's also good to be able to go from the higher levels to the lower. I mean, you can never go the other way because we don't know, but at least you can compress 9 levels into 4 if you need to. And when I first started making R packages, I would actually store this list, which it actually is, as a data object, because R can store data objects as well and then have people load that as data. But I found that that doesn't actually make sense for small data like this. So it's much easier to have it as a function and load it as that instead. Because data objects in R, number one, they're in this R data format, which is RDA, which takes a little bit more space and Git stores the entire object, obviously. So if I make a change of it, it kind of inflates the Git history quite quickly if you often need to make changes to it. While if you store it like this, it's just text, right? So the Git history remains pretty tiny, which I think is nice to think about. I think it's nice to think about. So before I do a very quick demo of like initiating a package project in R, go back here and talk a little bit about distributing. Because distributing R packages is not an arbitrary process necessarily. So if you want to go for cron, which is the repository of putting R packages into, it's going to require a lot of work. I would not bother for an in-house package. If you're distributing it to the world, yes, do it, go through the steps. But if you have an in-house package, cron is not the way to go. Even though it would make it easier for your users to install, it does require so much work that I don't think that kind of that balance pays off for us as developers. You can distribute it through GitHub by asking your users to install the remotes package and install using remotes install GitHub. I have found that this can be tricky for the networked Windows computer because remote checks for write accessibility in certain folders, which you do not have access to on a networked Windows computer by default. So you'll have to contact IT and they have to do the stuff. And it just ends up being a bit of a mess. But my bottom thing, oh, it expanded a bit more than it did on my other screen. Okay, I'll fix that before I put them online. So there's a new project by ROpenSci, which is a foundation that creates resources and tools for open science in R. They're a great initiative. They have great developers working for them. They're really doing such exciting things. And the R universe is something they launched either beginning of last year or the end of the year before that again. And it is so great. So Jeroen Ooms is like the main guy behind it. It builds package binaries just like Kran does, which means it's easy cross-platform installs. And you don't have to have your user install an extra package to install from it. It works like a type of Kran repository. And all you basically need to do is to have your package on GitHub and have a repository on GitHub called Universe and have a single JSON file in that repository. And then you get lots of stuff for free. And we're gonna have a quick look at the R Universe page for a project I have called ggseg, which is a plotting tool of brain segmentations from R. These are all the ggseg packages that I have. There are basically two pure plotting packages. So these contain the functions to plot the brain data, and all the other ones are atlases. So they are they're actually SF objects, so simple features, geographical objects, but as brains rather than maps. So you can plot your brain data like this, just like you would a map. It's just a brain instead. And you install packages from this universe basically by using this little bit of code in front. You basically tell R that the repositories, the online repositories, if it should look for packages is first this repository, which is ggseg, and then Kran, which means it will look for, if I'm installing ggseg chen, it will look for ggseg chen first in the first repository first, it will find it. If that package has other dependencies, which I know that it has, it will continue looking in ggseg. Knowing that it can't find it there, it will continue looking in Kran, where I know it will find it, and then it will install fine. It is so great. It even renders the user tutorials for you. There's an API using the REST API and curl, so you can grab information about the repository. You get badges. We all love badges, right? And you can even have a look, and this is all run through GitHub Actions. Like the entire process is run through GitHub Actions. So they kind of make a sub-repository based on your package JSON in that one repo you have. And then they set up this submodule system and build all your packages. And the build looks something like this. It is a GitHub action I have never seen the like of. It is pretty cool, but it's pretty awesome. So, and I have found installing from R using do. So I really like, even though it feels a bit weird to have a GitHub repository that literally contains a single JSON file. but it creates this whole extra ecosystem for you that someone else maintains basically, and this is what they do and they know what they're doing, and it just makes installs for your users so much easier. It's an amazing project. So I went a bit far here. I very much recommend if you're using R and you're making research software, or you're in general in a science related, following their and subscribing to their newsletter is really, really worth it. There's a lot of great resources there, and a lot of great staff to learn from. So still have 10 minutes. So, okay, we have 10 minutes for questions or for a very, very quick live demo. It's kind of up to you guys.
Thank you very much for the very interesting talk. Let's give the speaker a virtual round of applause. So there are a couple of questions in the HackMD. If you want, I can read to you, or you can.
I can. Where did it go?
This one. The first one is, how much do you account for the fact that different people collect and organize their data slightly differently? And the fact that there can be silly little errors with data, example given, what if one of the BDI columns was accidentally called the DBI? Would that get caught automatically, or would it be up to the user to notice that?
Yes, so that's a great question. So, I mean, I'm a bit, so I've set up the package so that in most cases, you can specify your own type of column names. So if you have another system of column naming than the one I've assumed you have, and the reason I can assume you have it is because I made the data. So like I also maintain our database. So I'm kind of the one that made up all these column names. So I know that the column names are correct, but obviously, if you're working on your own little, like you've made your own data sets, you have a side project and you haven't named the data in the exact same way that I would have, there are ways in the functions to work around that. And I've written a little bit about that in the documentation, but not extensively. Because in general, I would recommend people to rename their columns, because usually they're not named very tidily, if I can be so rude. My experience is that most people don't have a lot of experience in working in complex data. So they're kind of assuming that they have their 20 columns of data and they will always remember what those 20 columns of data are, also in 2 years when they haven't looked at it for 2 years. But usually they're named in a way where it's very, very hard to know in 2 years what the data actually were. So usually I would actually recommend people to rename their columns before they start working. But that's extremely opinionated, and I have a position where I'm allowed to be quite opinionated about these things. But it would not be detected automatically, and it would be up to the user to notice that things are working. But I think in most of the cases, things will start crashing possibly, or giving lots of NAs if it's incorrect, which I hope the user will notice and understand that something is wrong. I hope that answered your question.
It did, thank you.
The next question is, I started thinking, when you didn't have a dependency installed, is there a fast way to install all dependencies of a package you're working on while you're working on it?
No, it's not. But the thing is, well, you'll need an extra package for that. So there are ways of going around that, but it's generally the general consensus in the R community is that we shouldn't make things that force an installation on a developer specifically, because sometimes developers can be quite specific in the environments that we have and we work in. There might be a very, very good reason they don't want to update a package, or they don't want a package installed because it collides with something else. Who knows? In this case, like in most cases though, when you're developing a package, I mean, you'll already have the dependencies installed because you are making the package functions. So the dependency is already there. In this case, I hadn't worked, as I said, on this package for 2 years. So I'd forgotten that I'd worked with this one dependency that I don't actually like. So I'm refactoring this package and I'm taking away this dependency because it, now that I've kind of learned a bit more, I realized that it didn't make sense to have it there and to have its functionality there. It's meaningless. So there's no super easy way of doing that other than, actually there might be something in DevTools that I haven't looked at, but usually if I'm cloning someone else's repository to build on their package or to do a pull request for them or something because I found a bug, I will go through the dependency list in the description file and just install. I would just copy the list and install them. And for most packages, it's usually not that bad.
There's a third question in the HackMD. What advice would you give to RSEs that support communities where R is used to stay up to date? And for instance, be aware of such new and awesome developments like R Universe and R OpenSci.
Yeah. So subscribing to the R OpenSci newsletter is definitely a good place to start. And then following foundations like the R would likely give a lot of information, but by far, if you use a lot of stats hashtag, like I don't know how it is in other programming communities, but Twitter and RStats are in love with each other somehow. Like I get faster answers for my R-related coding questions on Twitter than I do on Stack Overflow, despite the character limitations. It's a very strong community. So I would recommend that. And then if you are a member of a gender marginal group, R Ladies is also a great place. Like I am not supposed to like toot my horn too much, but it is, R Ladies has a community Slack that is very, very active and is very, very supportive and is a great place to keep up to date with its developments. Because if you missed it, someone else for sure didn't.
Yes, thank you very much. Are there other questions from the audience or comments?
Okay, thanks for listening to me ramble on about R for an hour. I hope it was understandable, and please don't hesitate to reach out to me on Twitter or email or whatever. I'm very happy to discuss and help out where I can. And I'll put my slides online once I clean them up a little bit, and I'll send the link to Anne, and maybe then she can distribute it or whatever you, however you would usually do that.
Yeah, no problem. We'll put them online and be visible with a video.
With the video, yeah. You can catch the first slides that didn't move.
Yes. So Thank you very much, Mo. Let's give again a round of applause, and I'll now stop the recording.